9.9 Special Right Triangles Part 2. So this is now putting two triangles together. Makes it just a little more complicated. It says each figure below is a square. Find the length of side x in simplest radical form with a rational denominator. So we cannot leave a radical in the denominator. So if this is a square, I know all squares have right angles. And then if I cut this in half here, that makes each of these angles be 45s. So what I'm creating here is this 45, 45, 90 triangle. So I'm looking at this. Okay, remember the relationship that it's an isosceles triangle. These are my legs and I call them each L. So I do know what L is. And then the hypotenuse is just my leg times square root of 2. And since I know what L is, I'm going to just replace it in there. So I'm getting a square root of 10 times the square root of 2. I can multiply those under the radical, so that'd be square root of 20. I want to simplify that. And I know 20 is 4 times 5. Square root of 4 is 2 square roots of 5. So that's not bad at all. All right, number 2, same thing. So I know this is a 45, 45, 90. And I know these are my legs. And I don't know either of those measurements. I'm given the hypotenuse, which is my leg times square root of 2. So to solve for L, I'm going to divide by square root of 2. So that's what L is. But again, I can't leave it like this because of this radical in the denominator. So I multiply by that radical again. And the reason I do is because this over itself is really 1. So I'm secretly changing the problem without changing its value, because multiplying by 1 does not change a value. Multiply straight across, you get 4 radical 2 over, that's a square root of 4, which is really just a 2. So anytime I multiply a radical by itself, it's just that number underneath. And then 4 divided by 2 is 2. So 2 square roots of 2. All right, and then the last 3 says each triangle below is equilateral. Find the side length x. Okay, so equilateral meaning all 3 sides are equal. That means then that all 3 angles are equal. And 180 divided by 3 would mean this is 60, this is 60, this is 60. But divided in half would mean this is 30 and this is 30. So I'm dealing with a 30, 60, 90 triangle. Across from the 30, I always called that L. I know what L is, so all I'm going to have to do is plug that in. Across from the 60, that relationship is that it's a short leg times the square root of 3. So I'm going to plug in 8. So x would be 8 square root of 3, and I'm done with that one. Number 4, 30, 60, 90. This is L. I don't know it. This is leg times square root of 3 equals 10. Divide by square root of 3. So my leg is going to be 10 over square roots of 3, but rationalize it. Multiply by radical 3 over radical 3. That gets 10 radical 3 over that square root of 9, which is just a normal 3. And I'm done with that one. And then number 5. Okay, across from this is my leg. Across from this is my leg times square root of 3. I would have to divide by square root of 3. I can divide those. Leg would be square root of 2. And then to get the hypotenuse, which is what they're wanting, is double the short leg. So just fill in what you found for L. So x is going to be 2 square roots of 2. And that's it.